All right, pre-calculus, this is the second video on the 4.3 and 4.8 notes. We need to solve this triangle. Let's see, we were given two sides now. And I'm only given the 90-degree angle. What this is going to require, and when I need to find angles, is I need to use inverse trig. Before I get to that inverse trig, though, what I'm going to do first is use Pythagorean theorem, because I know those are good numbers. I can solve for my missing side. So if I use Pythagorean theorem, it'll turn out to be 65.8 squared minus 11.2 squared. That'll give me b squared, and then I would have to square root that to have my side b. So if you do that, lowercase b is about 64.84. Okay, now for my angles, capital A and capital B, this is where I've got to use inverse trig. I still need to think in terms of SOHCAHTOA though. So let's say I'm going to solve for angle A first. From angle A, I have an opposite and I have a hypotenuse. That's going to be sine. So I set up a sine equation just like I was doing. So sine of my angle, but I don't know it. So sine of A is opposite 11.2 over hypotenuse 65. Now I use inverse trig to get the angle by itself. So essentially what I'm going to do is take the inverse sine. Let me make a little room here. I'm going to take the inverse sine of both sides. So that's inverse sine. Now it's sine and it looks like it's raised to the -1. It's a poor notation, but it means inverse. So I have to do that to both sides. So what I end up getting is on the left side, the inverse sine of sine, basically they go away. And that leaves me with angle A is the inverse sine, so that's the inverse symbol, of 11.2 over 65.8. That's an 8. And figure out how to put this into your calculator specifically. You should get about 9.8 degrees. So there's angle A. Now for angle B, same start. I'm going to figure out what trig function to use. So for angle B, now I have the adjacent and the hypotenuse. That's going to be cosine. So I would say cosine of B is 11.2 over 65.8. Again, to get B by itself, I take the inverse cosine. Sometimes students will say, well, do I divide by cosine? No, I cannot do that because cosine is an operation. That's like saying, oh, I'm going to divide by the multiplication symbol or something like that. It doesn't make sense. So I take the inverse cosine. So B is going to be the inverse cosine of those numbers. Let me make some space again. The inverse cosine of 11.2 over 65.8, which is going to give you about 80.2 degrees, and we've solved it. Number 3 is kind of a tricky problem. We need to solve for x. Actually, let me shrink this down just a hair so I got a little more room. Oh, nope. There we go. Okay. So here's going to be my logic on this one. This one's going to take a few steps. I cannot directly figure out x. I've got to do it in a few pieces here. I'm going to look at the overall triangle, the overall yellow triangle first, and I'm going to figure out this entire missing side here, all the way from here to here. Let's call it, well, I've already got an x there. Let's call it A. To figure out that entire missing side, actually, let me stick to what I did, same variables I used on the notes. I called this Z, actually. Okay. Looking at the yellow triangle, that's going to be a tangent problem to figure out side Z. So tangent of the angle, which is 40 degrees, is Z over 400. I multiply 400 over, and I've got Z solved for. $122.96. Okay, now I'm going to look at this smaller triangle. Let's change the color here. This smaller right triangle. And I'm going to solve for this missing side, and I'm going to call it Y this time. Still going to be a tangent problem. Tangent of the angle, this time the angle is 28 degrees. Equals Y over 400. Multiply the 400 over, and I have that Y is about, oh, I wrote, sorry, my Z is wrong. I just realized you may notice that if you typed it into your calculator. Sorry about that. Z was, I was giving you the final answer instead. 335.64. There we go. Okay. Y is 212.68. And now to figure out X, I'm going to subtract these two. Z is the full length, Y is the bottom, subtract them. So if I subtract these, now here's where that number comes in, 122.96, that's my X length. So I had to use basically two triangles that were overlapping one another. On the back side here, we have some word problems. And the big thing on the word problems is correctly drawing them. So number 4, the angle of elevation of a flying kite is 67.13. You know what? Actually, I'm going to bring up this so I can do full screen of drawing. Okay, so you have the notes. So we have a kid flying a kite. So here's the kite. The angle of elevation is 67.13. So angle of elevation would just be this angle. So there's my angle of elevation. It says the other end of the 40-foot string. So I know the hypotenuse is 40 feet. It's held 2.5 feet off the ground. I'll use that 2.5 feet in just a little bit. The name of the game on these problems is figuring out where your right triangle is. And there it is. I want to know how high up the kite is. Well, how high up is going to be solving for this blue side. So that's going to turn into a sine problem. So sine 67.13 is opposite over hypotenuse. Multiply the 40 over, and my height is 36.86. But I still need to add on that little 2.5 feet. So this little bit here is 2.5. That child was 2.5 feet off the ground, or at least their hand was. So I have to tack on the 2.5 to get my final answer of 39.36 feet. For the next problem, we've got a mahi-mahi fish hooked on a 70 feet of fishing line, 10 feet of which is above the surface of the water. Okay, so let's draw out what we got here. We've got water. We've got a fish. We've got a boat up here. So I have a fishing line coming off of this. I know that fishing line is 70 feet, 10 feet of which is outside. That's going to matter because if there's 10 feet above or outside of the water, that means the amount that is underwater is 60 feet. It gives me the angle of depression. Now, angle of depression is from the horizontal of the water down to the line. That's an angle of depression. That's 40 degrees. And again, I got to figure out, all right, where's my right triangle? There it is. Question is, how deep is the fish? So I'll just call it D for depth. That's the side length I want to know. So looking at this triangle, it's opposite hypotenuse again. So this is going to be another sine problem. So sine 40 is opposite over hypotenuse. If I multiply it over, I've got 38.57 feet. Okay, I will go ahead and finish the rest of these problems because they're going to go pretty fast. That'll make this video a little longer, but we can endure. On number 6, a wheelchair ramp is to be built besides the steps to a campus library. Find the angle of elevation. Okay, so we've got a ramp. Basically, the steps are obviously putting the door above ground, but we need to have wheelchair accessibility. So we're going to have a ramp. Ooh, that's a terrible ramp. Let's try that completely again. I didn't like it. And a little better. So the angle of elevation of the 23-foot ramp. So the ramp itself is 23. So that's my hypotenuse on this triangle. Its final height has to reach 6 feet. I want to know what is the angle of elevation. So that's the angle I'm looking for. I'll call it theta. Oops, it's not a very good theta. Oh, that's even worse. There we go. So this is going to be that inverse trig again, but I'm still using SOHCAHTOA thinking. This is going to be sine. So sine of theta is opposite over hypotenuse. And like we did on the first problem on this group, I will then just take the inverse sine of 6 over 23. And that'll give my angle. It's about 15.1 degrees. For number 7, I'm going to go back to our Word doc because we have a picture with it. (7a), express the angle as a function of height. So on 7a, we're not actually getting a numerical answer. We're just going to get the function, the equation that we'll use on letter B. So I'm still thinking SOHCAHTOA. This one is going to be tangent. Oops. Email there. So tangent of my angle, theta, is opposite, which is the height in this problem, over adjacent, which is 2. All letter A wants me to do is get theta by itself, which means it's going to be inverse tangent. So theta is the inverse tangent of the height over 2. So that's all 7A wanted. 7B just says, all right, use that function you just made. So find the angle when the height is 3 miles. So I'm just going to plug in 3. So I'm just going to do the inverse tangent of 3 over 2. It's about 56.3 degrees. On the last problem, we have a telephone pole. We're going to assume that that telephone pole is vertical, hopefully. Not all actually are built that way, but we're going to assume it's vertical. And a 20-foot guy wire. So those wires you see coming off the pole, holding it in place to the ground. So this is the guy wire of 20 feet. And it's anchored into the ground 8 feet from the base of the pole. What is the angle of elevation of the wire? So angle of elevation, again, would be this. And again, I'll call it theta. Doesn't matter what I call it, though. So this is going to be an inverse trig problem, but I still have to think SOHCAHTOA. This one is going to be a cosine. So cosine theta is adjacent over hypotenuse. And then do inverse trig. Inverse cosine of 8 over 20. That is an 8, even though it doesn't look like it. And that'll give me about 66.4 degrees for my angle of elevation. Okay, that concludes the 4.3 and 4.8 sections, kind of morphed into one, notes.